Good afternoon. So today I'm going to talk about the work we are doing in the Cloud Computing Innovation Council of India on cloud standards and interoperability. This is kind of a topic which is close to my heart, and I hope by the time I finish it will be close to your heart as well. So here are the agendas for today. So first I'll talk about why do we need interoperability, especially in India. I'll talk about the current interoperability efforts that are going on globally, and I'll also talk about our efforts. And of course, if you look at our agenda, it's a lot better than the agenda on the right, which is a typical meeting where people turn up and then the projector is not working and those kind of things. We've taken care of all those problems here. So let me talk about the first question, which is why interoperability. So if you take a look at it, here is a cartoon which illustrates the point. I think initially, possibly, there was some sort of euphoria about the cloud, with a lot of things being taken, and with a lot of people just jumping in. But cloud is a complicated technology, and so people have realized that it's not just going ahead and doing stuff on the cloud. You need a well thought out strategy for that. And one of the important components of well thought out strategy is interoperability. You may have your own cloud, you may be using somebody else's cloud, you may be using multiple clouds for different reasons, and then how do you interoperate between these clouds? How do you make sure applications can talk to each other? I think over here the previous speaker was talking about CAS. I was listening to that, and he was talking about how do you share storage between containers and the data portability format. So that is again some of the things which comes into the effort we are doing. And so, but we are looking at it from a general point of view, that is, how can we lay down standards which make it possible for clouds to interoperate with each other? So let me briefly go over the reasons why interoperability is needed. So the first one, which you can see by this unhappy customer over here, he is locked into a particular vendor. He's gone with a particular cloud vendor, and that's kind of like proprietary software, and he cannot move away from that vendor, which gives the vendor power over that user. And this is not a minor thing when you think that the cloud may contain my entire IT infrastructure. So if my entire IT infrastructure is stuck with one vendor, then I'm really at that vendor's mercy. And this is particularly important for somebody like government. So imagine that government has some functions or something in the cloud, and then they're in a particular vendor and they cannot move out, or they cannot change vendors. The vendor is not giving satisfactory service. So government functions can come to a halt, and that would not be good. That would not be, no government can accept that, because government has to function. Even though we may think it's not functioning, it has to function. Okay, so the second, but that is only one reason. The second reason is given over here, and that is that if you remember in the beginning, the internet was just a series of isolated islands. There were companies like AOL which had its own internet, and other vendors also. They had their, like Sears had also got their own internet. They had got their own networks of computers where they had various resources you could look at, like shopping and so on. But then what happened was the TCP/IP and web standards got developed. And when that happened, every computer got onto the internet, and today we are seeing an internet revolution. So first computers got plugged together, then PCs, which made it possible for people to access the internet. Once PCs got on the internet, we got social networking, things like Facebook and so on, which is right now in a little bit of trouble, but still Facebook was a good thing. And then after that, now even devices are coming onto the internet, like you can monitor your blood pressure continuously, your heartbeat continuously, and these things are going to be even more useful as time goes by. Like things like Uber and so on would not have been possible without the definition of IETF TCP/IP standards, because if I have TCP/IP, that means I can connect my computer to any other computer in the world. That's guaranteed. So the TCP/IP allowed us to develop applications which can span the globe. So that is the real potential of the web as well. We should be able to develop application which spans clouds. So I may have different software service offerings, for example, like Salesforce and other things, and I should be able to just seamlessly meld them together. So one real life case which has been there is where the passport office wanted to automate the police verification part, and they wanted to connect to the police database and just automate the whole thing. And this took 6 months because there's no standard way of interoperation. So now imagine if I had to spend 6 months just developing the interface between two simple applications, how difficult it is to develop an inter-cloud application versus how difficult it is to develop a web application. Because in the web application, all these things like REST APIs, everything is very standard, and I can do it very simply. So we want to develop standards which will allow us to develop inter-cloud applications as simply as we do web applications. So that was kind of a look in the general kind of thing. If you look specifically at India, so what is it that we have and what is it that we can do? So if you take a look at things like Aadhaar, so I know there are security concerns about Aadhaar and so on, but suppose we can solve those problems, the security problems and so on. Aadhaar definitely gives us a very secure security infrastructure, because regardless of which cloud you're in, Aadhaar gives us a security way of doing security. Okay, so we have a security infrastructure. But there are other things, like for example, if you've got the data, so the government is now empaneling something like 13 cloud service providers for giving government services. Now, those are all very different, 13 different vendors, and the clouds don't interoperate. So suppose I've got, say, multiple state data centers as shown over here and a national data center. There could be applications running in these different things which are in different clouds. How do they interoperate with each other? Because, I can, let's say I'm state of Karnataka, I will send out a bid, vendor 1 will be the best and I will take that. Then, say Andhra will send out another bid, which I go to vendor 4. Now, how do these clouds interoperate with each other? So effectively, it means I cannot interoperate clouds. For example, suppose let's take the case of revenue. So suppose the income tax department cloud is overloaded, they would like to be able to borrow resources from, say, the service tax department, which is not, filing date is a different time. But if they're different cloud vendors and there's no interoperability, then that is not really possible. So this is the traditional application, but if the situation gets worse, when you go to the smart city kind of scenario. So in the smart city kind of scenario, let's say that there is garbage. There is a municipal authority which is responsible for garbage. So they will have their own system which monitors how much garbage is being generated, how much garbage is in different points. Now, I would like to be able to, in the ideal world, I would like to be able to link the garbage to the health statistics, so as to find out what is, if there is a garbage over here, is it adversely affecting the health of the individuals involved? But the health department, municipal health authorities, so they have some of the data because these diseases like dengue and so on, they are notifiable diseases. If a hospital gets a dengue case, they have to notify the health department immediately. But again, that would be on a different cloud. Now, suppose I want to develop an analytics application which merges together, say, the garbage and the health statistics to find out, okay, where are the points where garbage is really badly affecting the health of the citizens, how would I do it? So again, some of the questions the previous speaker was talking about come up. So I may have, say, in the health department, I may be running containers where data is stored in a certain format. How do I know I can import this data into the garbage program and do some analytics? I don't. Okay, in general, that will be a proprietary effort. So in general, if there are 10 data formats, I can have one of 10 data formats. That other person can have one of 10 data formats. So there are 90 possible combinations, and I have to do one of those 90. Whereas if there's a standard data interchange format which people can accept, then this whole process becomes much simpler because I know I can import any data from any other cloud. So things like smart cities and so on, they definitely need standards and interoperability. And again, we look at why India from another point of view also. So the chart on the left-hand side, that shows the different populations of various countries. Now you may be surprised to see that China is at 19% and obviously the biggest. We are at 17.5% of the world population, and the country which is next to us is the US, which is 4.5 times of the world population. So in terms of population, and if you think about it, the government services are in proportion to population. The number of hospitals, the number of garbage dumps, the amount of garbage we generate, the amount of traffic, the number of cars, all of these things are proportional to population. So in scale, we are 4 times larger than the next country, which is the United States. And if you take a look, after that, it becomes much smaller. If you take India and China, there are no countries which in population come even close to us, right? So therefore, we definitely need cloud. Without cloud, we are not going to have smart cities. We are not going to have all those other things which we are dreaming about today. The ease of filing income tax, all of those things are not going to happen. Cloud is needed. The second thing is shown by the thing over here on the right. So this shows the mobile phone. This shows the different countries, but the area of the country is proportional to the number of mobile phones there. So if you take a look at it, China is huge. India is next biggest, and maybe the US or Brazil is after that. Okay, so what happened with mobile phones? If you take a look at developed countries with like USA and Europe, what they did is first they had landline telephones. Then after that they had mobile telephones. Whereas in our case, we never had landline. Landline was never more than 5 or 6% of the population. But from 5 or 6% of the population having landline, we've gone to, I think, a huge majority of the population now having mobile phones. So we've leapfrogged that technology. We never went through a landline phase. So similarly, in cloud also, we have an opportunity to leapfrog. We have the opportunity today to develop cutting-edge applications in cloud and cutting-edge applications in big data. Because for scale, we need these things, and we have the opportunity to be leaders in this field. Because we are the biggest and we have the biggest problems. Okay, so that's an opportunity too. So the government is aware of this, and so they have set up a task force between 2 bodies. So one body is TSDSI, which is affiliated with the Department of Telecom, and this is a standards-making body for telecom in India. TSDSI stands for Telecom Standards Development Society India. That's what that stands for. And so they are developing India-specific requirements, standardizing solutions, and contributing these to international standards. The other is the organization which I'm part of, the Cloud Computing Innovation Council of India, and we are a non-profit society. So it started off as an organization under IEEE, and now it has become a non-profit society. And it's a collaborative platform. It's a volunteer-driven thing, like Aam Aadmi Party, if you'll excuse me for saying that, similar to that. We are all volunteers. And it's an organization which includes academics like myself. It includes people from government, like the Karnataka state government, and it includes, in fact, representations from the Department of Telecom and so on and so forth. It also includes people from industry like IBM, VMware, etc., etc. These are all people who have come and they're volunteering to be part of this organization. And our mission is to foster the growth of cloud computing. So we have worked in many areas. One of our earliest things was to develop a white paper which laid out a roadmap for cloud computing in India. We have played an advisory role to the government in many cases, such as when government has put out a bid for a cloud system, we have given advice on is the RFP good and those kind of things. And an example of that is currently with MeitY, which is the Ministry of Information Technology, we are collaborating with them to do a cloud study. So we have already initially done a cloud study which shows who are the people who are using the cloud in India, what are they using it for, what are their plans, are they planning to expand the usage in cloud. So this is like a business study which gives a picture of cloud usage in India. That's the cloud study. And MeitY, in order to set its policies, has wanted to do such a study. And so they have taken our help in doing that. and we are doing that effort. The other activity, of course, is the interoperability task force itself. So there is a joint working group, consisting of representatives from TSDSI and also volunteers from the Cloud Computing, CCICI, the Cloud Computing Innovation Council. And we are working together to develop cloud standards for India. So we have two objectives. One of them is to develop cloud standards for India. And standards are no use unless you can test them and verify that people conform to standards. So in addition to having standards, we're developing a test bed. We are proposing that there should be an interoperability test bed whereby people can run cloud software and make sure it is testable and so on and so forth. In the next part of the talk, so one of the things is there are many standardization efforts going on. I'll give an overview of a couple of these, and then I'll give an overview of what we are doing. So please stop me and ask me if you have any questions. And at the end, I will have a demo of what we are currently implementing. So if you take a look at the current interoperability efforts, there are standards that address one aspect of cloud. For example, SNIA has done pioneering work in developing cloud storage standards. But there are two bodies which are trying to develop a comprehensive overall standards for the cloud. And this one of them is the ISO, which is the International Standards Organization, and the other one is IEEE NIST. NIST is the National Institute of Standards and Technology of the United States. If some of you are familiar with cloud computing, you will be aware that NIST was the body which came up with concepts like infrastructure as a service, platform as a service. They are the people who came up with all of these basic concepts of cloud. They are a very influential body because it's a government body which is charged with making standards for the United States. So we think that these are two of the major cloud standards that are likely to be there, and those are the ones which we are taking a look at to identify gaps and to figure out where we should play. So I'm going to talk about those now. So first, let me talk about ISO, and the standard is called IEC 19941. So ISO actually, in a sense, is a model. So what it does is it tries to establish what are the standards we need for cloud. So suppose, for example, we say that in order for interoperability, security is needed. So then ISO IEC 19941, it defines what do we mean by security, what are the functionality which is needed by security. So it's like a model in a way. So the idea is that by specifying clearly what is meant by security for interoperability, there can be common understanding between cloud vendors and cloud customers, and and then they can also share a common vocabulary. So when I say cloud security, I don't mean something different from what you mean. So the way they have done it is they have defined what's called a facet model. So there are three facets they define. One facet is cloud interoperability, the second is cloud application portability, and the third facet is cloud data portability. So I'll go over each of these three right now. So if you take a look at the cloud interoperability facets, so as an example, let us take the top one, which says, and the first column contains all the facets. So transport is a facet. Syntactic, that is the format of the data, is a facet. Semantics means what does the data mean. That's another facet. Behavioral, and then policy. So policy is things like regulatory and organization policy. Security, for example, falls into policy. If there are restrictions on cross-border data platforms, there's policy. So if you take the first one, for example, IEC 19941 defines transport as a facet. The aim is to ensure that there is data transfer between systems. And the requirement is that the data transfer should be according to some well-established protocol. And the examples they're given are REST-based HTTPS, and MQTT, which is an IoT transport protocol. So the cloud interoperability facets has there are 1, 2, 3, 4, 5 facets to cloud interoperability. What is the meaning of each facet is also defined, and they're given examples of standards which can be done in these. Sorry. Oh, my apologies. I have inadvertently omitted the cloud portability facets, but I do have the cloud data portability facets. So again, the cloud data, let me also explain in an intuitive way what's the difference between interoperability and portability. So interoperability means simply that if I have two clouds, then I can work with the clouds using some common APIs. I can use APIs, say if I want to create a virtual machine in one cloud, I have similar APIs which will work across clouds. That is what is meant by interoperability, whereas portability simply means that if I can run Oracle, for example, in Cloud 1, I can also run Oracle in Cloud 2. So that is application portability, and there are a number of facets which are defined for what is exactly meant by application portability. I mean, I gave an intuitive definition when I said that applications can run here can also run there. So what does that really mean? That has been broken down into some details in the application portability facet. So now it's not only necessary to have application portability, but as the previous speaker was saying, and as I had also given some examples, the data also needs to be portable. So what is the data portability? So according to them, there are 3 facets of data portability. So first facet of data portability is that the data has to be in a machine readable, structured, and commonly used format. So we should have a standard for defining what is the structure of the data. Examples of that are XML, CSV, and JSON. Okay, so these define the structure of the data. Then there's the semantics, which is the meaning of the data, and that is done by creating ontologies, common ontologies, or metadata. So example of this is OWL, or Dublin Core Schema, which gives the meaning of the data. And finally, the third thing is the data policy. So the policy includes things like what is the confidentiality level, what is the privacy right on the data, and what are restrictions on cross-border transfer. So these 3 facets define what is the meaning of data portability as per the ISO standard. So if you look at the ISO standard, it is at a high level, and it is, in a sense, a model. That is, it gives sort of like what are the requirements. So if I look at the data portability model, it says that what I require is a common syntax, and examples of common syntax are given. What I require is some common semantics, and again, examples of that are given. And then I need policies for managing the data. So I can't just move data from one place to another place and so on and so forth. So this is essentially the summary of the ISO IEC 19941 standard. I will now move on to the next one, which is the IEEE NIST P2302 standard. So in the case of ISO, the idea is to create a common terminology, common understanding, and so on and so forth, whereas the NIST has a different objective, which is to create a cloud provider ecosystem, which is transparent to users and applications. It also includes an economic component, and it is also dynamic. So the infrastructure is not static and predefined at one time, but it's also dynamic. That is what it says. So IEEE P2302 standard is defined in terms of federation. Thanks. Federation is the key. So I'll go quickly over some of these because I think we're almost out of time. I will want to show the demo also, which I have. So federation, in a nutshell, means that organization A discovers and invokes services in organization B, And organization B is the cloud. It can validate organization A credentials and make the correct access decision. So to make this concrete, it defines two kinds of federation. So one kind of federation is called user to cloud federation. So let me give an example of this using telephones. So suppose I want to, that Prince Harry and Meghan Markle got married recently, and suppose I want to call up Meghan and say, hey Meghan, congratulations. So how will I do this? So the user to cloud federation is something like this. I have a directory which is called the federating agent where I can find out Meghan's telephone number. And I find out the telephone is in UK. Now I have an India SIM in my phone and a UK SIM. So I'll use the UK SIM to make a phone call to that. So this is like I have a federation broker which says what resources and what cloud, and then I have a way to access the different clouds. So I as a user am accessing different clouds, I'm getting resources, and what I do with them is my business. That's it. Then we have the second kind of federation, is probably more useful. This is called cloud-to-cloud federation. This is like a telephone call. So reality today, if I want to call up Meghan Markle, I will dial her number, and then the phone call will first go to Airtel, which is my service provider, and then they will see it's a UK number and they'll send it to the correct place. So similarly, in this cloud-to-cloud federation, the user makes a request to one cloud, and the cloud will give the request either from its own resources or it's federated with some other cloud. It will get the resource from some other cloud and attach it over here. So that is probably a more useful kind of a thing. So I'll quickly move on to our approach. So we have taken a look at both ISO and IEEE NIST. So next question is, what is the value of interoperability? So I've given it at a general high level, but these are spelled out in detail, that if it's smart cities, this is what you can do if you have cloud interoperability, but if you don't have it, this is what you cannot do. What is the value for governments, for vendors, and so on and so forth? Identify the gaps in these standards. And then we'll take important India-specific use cases. So we want to develop standards which are for India because we have a scale and we have an infrastructure which is different from the rest of the world. Of course, a lot of the standards will be common and we don't want to reinvent anything, but we'll take India-specific use cases. And we need to take IaaS use cases where the interoperability questions are like, how do I create a VM and so on. PaaS interoperability cases where, as the gentleman was saying, how do I exchange data between different PaaSes and so on. SaaS interoperability use case also have the data question, in addition to what are some common APIs I can do to take multiple SaaS applications and develop a combined application. So currently we are looking at two use cases. One of them, infrastructure as service, is the e-governance use case, which I went over very briefly. That is, suppose one government department wants to say it's overloaded and wants to get resource from another government department, say VMs in another government department. How does it do that? And the second, for the SaaS use case, we've taken smart cities. Suppose there's a garbage application and say health application, and we want to do analytics across all of these, then what is the cloud infrastructure we need? So we'll do that, we'll define standards and do the interoperability test bed. So now let me quickly go over the demo which I had, and then any more questions. So we are working on building an OpenStack cloud which can federate any two OpenStack infrastructure, can federate any two OpenStack clouds, and we want to give this as an offering to OpenStack so that between any two OpenStack clouds there will be interoperability guaranteed. So this is the architecture. I'll briefly go over that. Yeah, so this is the architecture of our solution. So if you take a look at it, the OpenStack consists of a number of services which are shown over here. So for example, if you take C, that stands for Cinder, which is the one that creates logical volumes. And if you take N, that is Nova, that creates virtual machines. So what we've done is we federated this across two clouds using proxies. So there will be a Cinder service running in this cloud. There will also be a Cinder service running in this cloud. Essentially, what we've done is we federated these two Cinder services. Okay, we joined them together so it looks like one service. So when the user submits a request to create a logical volume, because it's a federated service, it can go either here or there. So the advantage of our approach is that we are adding a layer on top, a federation layer. We are not going into cinder code, which creates logical volumes, and changing that. We are not doing that. We are adding a layer on top which federates cinder from one cloud to another cloud. So even if OpenStack comes up with a new release which modifies cinder greatly, it doesn't affect us as long as the APIs remain the same. And the APIs to some extent will remain the same because changing APIs has a lot of effects on the ecosystem. So essentially we built a federation layer which can federate multiple OpenStack clouds. So here we'll show a demo of the distributed resource service. So we are going to show that by logging. So what we actually do as a result of the federated service. Suppose you've got two clouds A and B. Then the resources which are available in cloud B, it will look like a subcloud of cloud A. That's what it looks like, and we will show that over here. And we are showing the UI for both clouds just for clarity. In reality, if you log into one cloud, you see the resource of all the federated clouds. So here we are doing that. And so these are the local cloud instances. And if you take a look at this one, this is a VM in the remote cloud. You can see it's from the remote cloud because it's prefixed by an IP address, whereas the resources of local cloud simply have the name. So obviously this is a convention because of POC, we would change that later. So let me jump, it's just more stuff which is there. So let me jump to some random point. This video is available on YouTube. You can take a look at it in detail. We show a lot of interesting cases like how can you create a logical volume in a remote cloud? How can you take a logical volume in a remote cloud and attach it to a VM in the local cloud and so on and so forth. Okay, so this one is about images. So you can create we have federated glance, which is the image storage service of OpenStack. And so therefore you can create an image in a local cloud and you can access it from any other cloud. So there's a centralized image store, which means you don't have to worry about inconsistencies of images and so on. So I think we are kind of out of time. So let me just, instead of going through the demo, let me just ask if there are any questions. Maybe that may be better. If I'd be happy to answer any questions in the few minutes we have left. So the advantage of having, say, attaching a remote local volume to a VM in a remote cloud is, suppose I don't have enough resources for VMs in my local cloud, then I can just create a VM, but without transferring the data, have the data access be in my local cloud. So that's the advantage of that. So there are a lot of interesting use cases like that, which I'd request you to take a look at on YouTube. So I'd be happy to, yes, please go ahead. So the question is, are we working with NIC? Answer is yes. We have invited them to participate with us. That's one of the government agencies, and we haven't signed the formal agreement and all that yet. But we do definitely expect them to work with them. Yes.
Yeah. So in the federated cloud. So you are kind of distributing the resources into multiple OpenStack clouds. So this solution also provide in which you can move the resource, like you are creating the cinder volume from one OpenStack cloud to another. Is it possible?
Sorry, could you please repeat the last part?
Can you move the resources like cinder volume from one OpenStack cloud to another OpenStack cloud?
So we can copy the data, but moving, see the basic thing is the logical volume is built on top of physical volume, which is attached to one cloud. So currently you cannot, if you want to actually move that logical volume, you have to detach the physical resource from one cloud and then put it to another cloud, which currently is not possible. So we can copy the data, we can snapshot the data, we can mirror the data, all of those things are possible, but physically moving the logical volume is not possible. So I wanted to end it with one final thing, and that is, if any of you are interested in participating in this effort, please contact me. You can become a member of CCICI, and you can join this effort. So CCICI is working with the government a lot of cloud standards, cloud activities, and we expect that to expand in the years going forward. And you're welcome to come and we invite you to come and join us and help draft a cloud strategy for India. Thank you.